Hello, today our group including me, Pranay and Gunt.A are going to present our DIY celestial sphere. Let's start from introduce each part of the celestial sphere. Sorry, for the white paper with the labels, you'll see the it's called celestial equator. It's basically just an Earth equator that projections into the space. And for the blue line, this is the sun part, or we call it ecliptics, it's the part that sun takes along years. And next I will explain the 4 points of interest in our system and the difference between day and night time and also the sunset. For the first 2 points, it is where ecliptics and celestial equators cross each other. It is the vernal equinox at the right ascensions of 0 hour and autumnal equinox at the right ascensions of 12 hours. There's not much difference between these 2 points except for it's directly opposite each other. For the sunset, it sets on exactly east and it rises on exactly east, and sets on exactly west. So the sun takes equal times among day and night. In total, we have 12 hours of day and 12 hours of night. But things get different once we come to summer solstice or the point here. It is a point where the right ascension is 6 hours and the declination is plus 23.5. The sun gets into the north part of the celestial sphere, so it takes longer part in the daytime. In total, it have like approximately 15.5 hours in day and 8.5 hours in night. So when you see this, it's going to rise. The sun is rise in the northeast and sets in the northwest. It's get opposite in the winter solstice. The daytime is approximately only 8.5 hours, and for the nighttime it is 15.5 hours. And it sets it rises in the southeast and sets in the southwest. So at this point, the right ascension is 18 hours and the declination is negative 23.5 degrees. And next I will explain the part our system of watching the star. It is an equatorial system. Let's start from the right ascension. The right ascension is measurements of eastward and westward when compared to the vernal equinox, or we use it as our reference point. The right ascension range between 0 hour into 24 hours. So basically it's just the times of the day. And for the right ascension, for the declination, it is a measurements of how upward or northward and downward or southward compared to the celestial equator, or we use this celestial equator as our reference planes. So it's range from like negative 90 at the very bottom or the very south pole, and into plus 90 degrees at the very north pole or north celestial pole. And next Gun will explain the rest.
Next, I will identify the declination for the horizontal system. So we can find the star declination by measuring its altitude when it is still south on the meridian. Formula for 46 degree north is declination equal altitude minus 90 degree plus latitude. So for the 46 degree north will be declination equal altitude minus 44 degree. So for the example, for the star at the zenith, so it will be here directly overhead. So for the observation, the star is at 90 degree altitude. For the calculation, it will be 90 degree minus 44 degree. So it will be, so for the star declination will be plus 46 degree. And next, I will identify the circumpolar star. So for the circumpolar star is never set at 46 degree north. This region is quite large. For the rule, a star is circumpolar if its declination is greater than 90 degree minus latitude. So for the calculation, is 90 degree minus 46 degree equal 44 degree. So any star with declination greater than plus 44 degree is a circumpolar star. So if you can see here from the NCP down 46 degree, 44 degree and upper will be circumpolar star. So thank you for your kind and this is this is all of our presentation. If you have any question, feel free to comment. Thank you. Let's go. ได้ปะ